Hi friends, welcome to my channel. Today I am going to explain you motion and time of class 7 physical science. After this video, you will be able to tell what is motion, what is rest, how motion is relative, what are the types of motion, how to measure speed. First of all, what is speed, what is uniform and non-uniform motion, what is time, how did our ancestors measure time, science of the simple pendulum, and how to draw a graph. Let's start. When do we say an object is in motion? Motion can be defined as the action or process of moving or being moved. An object is said to be in motion if its position with respect to its immediate surroundings changes with time. This again depends on the observer. And in the case of rest, when the position of the object with respect to its immediate surroundings does not change with time is known as rest. This also depends on the immediate surroundings. Let's look at the examples for better understanding. In the first example, the boy and girl are walking on a street path. Here, their position is changing with respect to time and their immediate surroundings. And in the second example, the two girls are sitting on the bench and watching. But here, their position is not changing with respect to the immediate surroundings and time, but the butterflies and birds are moving, so they can be considered as in motion with respect to the time and immediate surroundings. All motion is relative. An object may be considered in motion or in rest by an observer and can also be considered as rest by another observer. Here, in this example, the boy on earth is observing the ball. For him, the ball seems to be at rest as both are moving, as both are on the earth and the earth is moving. As both are moving, it seems to be rest for the boy. For the astronaut who is observing the ball standing on the moon, seems to be at motion as the moon is moving around the earth or revolving around the earth, and also the earth is moving, so it seems to be at rest for the astronaut. Now let's look into the types of motion. There are many types of motion: linear motion, vibratory motion, circular motion, periodic and non-periodic motion, rotation motion or rotatory motion, revolution motion or revolutory motion, and oscillatory motion. Now let us define all the motions which I have mentioned before. Linear motion, motion along a straight path. Its other name is rectilinear motion. Vibratory motion, very fast to and fro motion. Circular motion, motion along a circular path. Periodic motion, motion that repeats itself after periodic intervals. Non-periodic motion, motion that does not repeat itself after periodic intervals. Rotatory or rotation motion, the motion that occurs when an object rotates on its own axis. Revolutory motion, motion in a circular or an elliptical fixed path around a certain axis. Oscillatory motion, to and fro motion in a slow or medium speed. Now let's learn uniform and non-uniform motion. An object is said to be in uniform motion when it moves along a straight path covering equal distances in equal intervals of time. For example, car A travels 30 kilometers in 1 hour and 30 kilometers in another hour, and like that. So for 4 hours it travels. So it travels 120 kilometers in 4 hours with uniform motion. Non-uniform motion. An object is said to be in non-uniform motion when it covers equal distances in equal intervals of time. Suppose the same car on another day travels on a straight narrow road with lot of traffic on it. It continues to travel straight, but its speed does not change equally with respect to time. Now let's learn about time, and also let's look into the example of uniform and non-uniform motion. In the first example, the green car travels equal distances in equal intervals of time with equal speed. So this can be considered as uniform motion. And in the second example, the yellow car is traveling with different speeds and stopping in different intervals of time. So this will be considered as non-uniform motion. Now let us learn to describe straight line motion. We need to mention the position of an object to describe its motion along a straight path. Consider the motion of a car along a straight leveled road. Choose point O as the starting position. This means the car is at position O at time is equals to 0. Let A and C represent the position of car at different intervals of time. A. Time is 10 minutes and the distance traveled is 60 meters. B. Time is 20 minutes and the distance traveled is 120 meters. Now, let us learn speed. First of all, what is speed? Speed can be defined as the rate of rapidity of an object or how fast an object moves. In our daily lives, we come across two common situations. Different objects may take different time to cover the same distance. Here, we call the object as fastest, which takes the least time. And different objects may cover different distances in the same time. Here, we call the object as fastest, which covers the maximum distance in the same time. Now let's learn to measure speed. The formula of speed is equals to distance per unit time, or speed is equals to distance by time, or s is equals to d by t. In s is equals to d by t, speed is represented with s and distance is represented with d and time is represented with t. In some situations, we need to measure the average time, like if a bus was on a road trip to Shimla. If a bus is on road trip to Shimla from Hyderabad, there may be some variations in this speed. So here we need to calculate average speed. So the formula of average speed is total distance by total time. Now let's learn what is time. Time plays a very important role in our lives. Any change or movement which takes place in our lives is understood in terms of a physical dimension called time. Time and change are linked together. Natural events like solar and lunar eclipse happen once in a while. Other natural events repeat themselves over a period of time, like the appearance of Halley's comet, occurrence of seasons, days, etc. They are called periodic events. Periodic events are the events that repeat themselves after a fixed interval of time. Now let's learn how ancient people measured time. In ancient times, people did not have any watches that we have, so they measured time by using such natural events. Time between one sunrise and the next was called as a day. Similarly, one full moon to new moon to the next was known as a month. An year was fixed as the time taken by the earth to complete one revolution. Measurement of time. For us, there are many devices for measuring time like stopwatches, watches, digital watches, clocks, which help measuring the time very precisely. But in ancient times, they did not have this technology. And how did they measure time? The early scientists developed some devices to measure time, that is, sundial. It shows the time with the direction of the sun and its shadow. Sand clock. It is used to measure perfect time intervals. It has some sand and two chambers as shown in the picture, and also has a small hole in between the two chambers so the sand falls. This was used for keeping timers, stopwatches, and also for measuring time. There are also many types of other ancient clocks like water clock and simple pendulum. Now let us learn how the simple pendulum works. Simple pendulum is an ancient device used to measure time. It has a metal bob tied to a taut light string, and the other side is tied tightly to a rigid support, leaving the metal bob freely so it can oscillate. The simple pendulum is based on oscillatory motion. When the pendulum's bob is at rest, it is known as in equilibrium position. The simple pendulum uh, is based on oscillatory motion. The movement of the pendulum bob from one extreme end to the equilibrium and to the other extreme and again to its mean position and then finally back to the initial extreme position is called one oscillation of the pendulum. The time taken by the pendulum to complete one oscillation is called as the time period of the pendulum. Discovery of oscillatory motion. The pendulum was discovered by Galileo, which we'll learn in brief in the upcoming slides. In athletic races and other type of races, stopwatch is used to measure time very precisely. It can be started and stopped whenever we want. Discovery of oscillatory motion. Discovery of oscillatory motion of pendulum was discovered by Galileo in the late 1602. When he was small in the church, when the candle lamps hanging on the ceiling were moving periodically by the breeze, he observed that it was periodic and measured the time for an oscillation by counting beads on his wrist and measured the oscillation on the other side by measuring the counting of the beads on his wrist and observed that those were same. These observations helped him understand and formulate the basic ideas about the simple pendulum. Automobiles are fitted with odometers for measuring the distance traveled by them. Nowadays, we have quads, crystal clocks, digital watches, and many watches. The time should be measured very precisely in athletic races and other types of races. So, stopwatch is used to measure time very accurately. Graphs. Graphs are used to represent data in an attractive and easily understandable form. Mostly, graphs are used in maths and science and in other fields of study. There are many types of graphs, but in science, mostly line graphs are used. Distance time graph. The yellow line represents fast or steady speed. The blue line represents decreased in speed. The graph looks like this for decrease in speed, and the graph looks like this when the object is in fast or steady speed. When the object is increasing its speed, its graph looks like the red one, and the green shows the steady, stationary, and returning to start motion of the object. Thank you for watching my video. If you liked it, please like, share and subscribe. Also, do watch our other videos. Bye.